Sewage treatment is the process that removes the majority of the contaminants from wastewater and produces both a liquid effluent suitable for disposal to the natural environment and sludge that can be used as manure. To be effective, sewage must be conveyed to a treatment plant by appropriate pipes and infrastructure, and the process itself must be subject to regulation and controls. Other wastewaters require often different and sometimes specialized treatment methods. At the simplest level, treatment of sewage and most wastewaters is through separation of solids from liquids, usually by settlement. By progressively converting dissolved material into solid, usually a biological flock, and settling this out, an effluent stream of increasing purity is produced. The objective of sewage treatment is to stabilize decomposable organic matter present in sewage to produce treated sewage and sludge, which can be reused for non-potable purpose like flushing, gardening and so on. The excess water disposed off into the environment without causing health hazards or nuisance. The following shows the stages of sewage treatment process in a sewage treatment plant. Bar screen chamber. The function of the bar screen is to prevent entry of solid particles above a certain size, such as plastic cups, paper dishes, polythene bags, and sanitary napkins into the STP. The screening is achieved by placing a screen made out of vertical bars, placed across the sewage flow. A typical bar screen chamber, which is shown here. The platform is provided with weep holes, so that the operator can leave the collected debris on the platform for some time to allow inbound water and moisture from the screened debris to drip back into the chamber. This not only reduces the weight and volume of trash to be finally disposed of, but also reduces the nuisance of odor coming from the putrefying matter. Equalization tank. From the bar screen chamber comes to the equalization tank. The equalization tank is the first collection tank in an STP. Its main function is to act as buffer, to collect the incoming raw sewage that comes at widely fluctuating rates, and pass it on to the rest of the STP at a steady flow rate. During the peak hours, sewage comes at a high rate. The equalization tank stores this sewage, and lets it out during the non-peak time when there is little incoming sewage. The daily flow of sewage varies from peak flow to lean flow, in order to equalize all the characteristics and flow of sewage before it is subjected to treatment. The sewage is collected in the equalization tank, where the solids are kept in suspension by blowing air and avoiding septicity. Air blowers. Proper aeration and blower selection are two of the most important considerations at a wastewater plant. Here in the plant there are 4 air blower, which is divided in pair of 2, where one air blower acts as a standby when the other is in operation. This is done to reduce the load of work for one air blower by switching between them at different intervals of time. This ensures continuous operation of blowers throughout the treatment process. The essential function of an aeration control system is to fulfill oxygen demands and maintain the treatment process at the lowest possible costs. A common measurement of proper airflow for the treatment process is to check the dissolved oxygen concentration. Back to the equalization tank. Here continuous aeration is provided from the air blowers through diffusers, which is placed at the bottom of the tank. The equalization tank also acts as an aeration tank. Its main function is to maintain a high population level of microbes. Here coarse bubble aeration is adopted by air diffusion through perforated PVC pipes. OCM chemical is added into the tank every day. This chemical is added to control the odor generated from the tank. After sewage water reaches to a certain level, it is lifted through set of sewage transfer pumps. Sewage transfer pumps are used to lift the sewage water from the equalization tank to the SPR tank. Here one acts as a standby while the other is in operation. Sequencing batch reactors, or SPR for short, treat wastewater such as sewage in a batch treatment process. Oxygen is bubbled through the wastewater to reduce biochemical oxygen demand and chemical oxygen demand, producing a high-quality effluent with a low turbidity and nitrogen levels capable of meeting the effluent quality standards. This is a biotechnology where a particular type of microbes are seeded into the SBR tank initially and allowed to proliferate by consuming oxygen. Oxygen, which is being supplied by air diffusers. Continuous aeration is done for growth of microbes. Minimum hours of aeration is done once the SBR tank is full. Then 1 hour settling is done, so that the sludge will get settled down in the SBR tank. Decanter valve. Here, after 1 hour settling in SBR tank, decanter valve will open automatically so that only the fresh water will flow to the decanter tank. Decanter tank's purpose is to hold the fresh water which got separated from solids which comes out from the SBR tank after 1 hour settling through the valve. Once fresh water in the decanter tank reaches to a higher level, filter feed pumps will be switched on. Here, sludge removal pumps are used to lift the sludge settled down in the bottom of the SBR tank to the desludger and excess to sludge holding tank. The other purpose is to recycle the sludge from SBR tank to the collection tank. Here, one pump acts as a standby while the other is in operation. Centrifugal desludger is used in the process which uses the force developed by fast rotation of a cylindrical drum or bowl to separate the sludge solids from the liquid. In the basic process, when a sludge slurry is introduced to the centrifuge, it is forced against the bowl's interior walls, forming a pool of liquid. Density differences cause the sludge solids and the liquid to separate into two distinct layers. The sludge solids cake and the liquid centrate are then separately discharged from the unit. The excess sludge is sent to sludge holding tank to be disposed of. Coming back to the decanter tank, the water stored in the decanter tank is then lifted by filter feed pumps. Filter feed pumps. Water from decanter tank is lifted to pressure sand filter by a set of filter feed pumps. Here, one pump will be operational and the other will be on standby. Pressure sand filter, or PSF for short. It consists of a pressure vessel, either vertical or horizontal, with a set of frontal pipework and valves. Graded silica quartz sand supported by layers of graded underbed consisting of pebbles and gravels. A top distributor to distribute the incoming water uniformly throughout the cross-section of the filter. These filters are the most popular method for removal of turbidity from water. The pressure sand filter consists of a multiple layer of sand with a variety in size and specific gravity. These filters are designed to remove turbidity and suspended particles present in the feed water with minimum pressure drop. These filters are custom designed to suit the process requirement. These filters are offered in mild steel, FRP or SS construction with face piping and associated valves. After its process, the filtered water will be sent to activated carbon filter, or RCF for short. It is designed to remove free chlorine, organic matter, odor and coal present in the raw water and wastewater. Due to its high degree of microporosity, activated carbons provide a huge surface area. Activated carbon filter operates through adsorption. Adsorption is directly related to the surface area of the media. This great surface area furnishes a huge adsorption area for organic as well as chlorine molecules to attach themselves. The activated carbon filters consist of activated carbon granules supported by very fine quartz filter media. Various grades of carbon are used for specialized treatments. Backwashing. The filter is then taken out of service and cleaning of the filter media is effected by flow reversal, also called as backwash. To assist in cleaning the bed, the backwash operation is sometimes preceded by air scouring by way of agitation through the under drain system. The air scouring agitates the sand with a scrubbing action, which loosens the intercepted particles. The filter is now ready to be put back into service. After the process of filtration from pressure sand and activated carbon filters, treated sewage water comes out from the filters, which is disinfected using chlorine dosing system. The treated water is disinfected to destroy and render harmless disease-causing organisms, such as bacteria, viruses and so on. After chlorine disinfection, the treated water goes to the treated water tank. It is the final stage of the sewage treatment process. The treated water tank purpose is to store the treated water so it can be reused for flushing and gardening. Here, we see the final quality of the treated water taken from the filters.